Today's lesson is 7.3, the number E. The natural number, or the natural base, or Euler's number, is E. E is about this decimal right here, and notice it does continue forever, uh, and there is really no pattern to E. E is helpful to help us compound interest. It helps us in our compounding interest formula. If you remember from a previous lesson, the compound interest formula was this. So let me go ahead and write that down. All right, let's go ahead and take a look at the natural basis graph. We're going to go ahead and graph f of x equals e to the x power. We're going to identify its asymptotes. We're going to identify the y-intercept, the domain, and the range. So let's go ahead. Let me squeeze out of here for just a minute. There we go. And let's go over to Desmos and let's put in this function right here. Let me show you how to do that. So let me open Desmos. Now, if you look on my keypad right here, there is no E. But right here in the lower left corner, there is this AB button. And so I'm going to go ahead and press that to change to my keypad. Now, if you're on your laptop, you just need to find E on the keypad. So we're going to put in the letter E, and then we're going to come back and we're going to raise it to the variable X. And there's our graph. Since it is a graph, I can click the little widget and I can go ahead and look at the table. Now this table isn't really giving me a lot to work with. So what I'm going to do is I'm going to add, let me see if I can go back, done. Okay, I'm going to leave it because, no, let me go ahead and come back. Oh no, what happened? All right, let me go back into Desmos and see if it'll work for me again. There we go. Let's put it back. Sorry, I was trying to be cute and it didn't work. All right, e to the power of x is a graph that is between 2 to the power of x, which we've seen before, and 3 to the power of x. So let's go ahead and put both of them in. Notice my e of x, which is in red, is right in between my 2 of x and 2 to the x and 3 to the x, which are in blue and green. They share a common point, and they share, which is the y-intercept, and they share the asymptote, which means they're all kind of coming and skimming down and touching the x-axis, but never really touching it. So let's go ahead and go back to our notes, and we're going to go ahead and we're going to put this, and then I'm just going to kind of put the shape of the graph. And our asymptote is going to be right here at the at the x-axis, which remember is the equation y equals 0. So my asymptote is at y equals 0. My y-intercept, remember you're finding the y-axis, you're coming down until it hits the graph. There's the graph, and it's right there at 1. If you wanted to think of it as an ordered pair, it would be the ordered pair 0, 1. There we go. Remember, your domain is your x values. Your domain is your x values. Your x values are only hindered by a vertical asymptote. There is no vertical asymptote. There's none at all. I'm just making these up to show you what they would look like. There's none at all. I can see the graph right here in the negative portion of x, and I can see the graph right here in the positive portion of x. There is no restriction to it, so my domain is going to be all real numbers. Negative infinity to positive infinity, if I needed to write it in interval notation. Negative infinity to positive infinity. Now my range is going to be stopped by my asymptote, because see my asymptote right here says y equals 0. So my range is going to be y and 0, and I have to decide if they're the y values bigger than 0 or the y values smaller than 0. So I have to decide, is it greater than or is it less than? And I have to decide. So I'm going to look at 0. Here it is. my asymptote, and I'm going to look at my graph. And I'm going to focus here on the y-axis. These are the y values that my graph contains. These are not the y values that my graph contains because the graph is not down there. So all those values in the circle up above, right here, they're positive. So I can pick any of them, like 8. Is 8 bigger than 0 or smaller than 0? Well, 8 is bigger than 0, so I'm going to put greater than or equal to. If I were to write it in interval notation, 0, comma, positive infinity, and I'd use the parentheses because neither one are contained. All right. In the very first lesson that we talked about in our exponential unit, we looked at this form of our exponentials. And we're going to go ahead and look at this again. And I just want you to remember how each one of these letters makes the graph move, like H. H is going to translate my function to the left or to the right in my x direction. But remember, H is tricky. So when H looks like -2, H really equals +2 and is moving your function to the right. When H looks like +2, H is really -2 and is moving your function to the left. K, which is after our variable x, is going to move my function up or down in the y direction. Since k is outside of the variable, it does what it looks like it does. So if it looks like this, +2, that means k is +2, and it's going to move my function up 2 units. If k looks like this, -2, that means k is -2, and it's going to move my graph down 2 units. B, my base, for this lesson, my base is going to be my natural number e. And anything that I put in front of e here at a is going to just change how quickly my function grows or decreases. Okay, so we're going to go ahead and describe the transformations, and one of your assignments today is going to have the f of x equaled, and then it's going, or graphed, and it's going to make you move it, just like in the last one with the base 2 or the base 3 graph. You're going to have this graph graphed for you, and you're going to have to move it. You don't have to go to Desmos because you can use H, K, and A if needed. So I'm just going to come right here and I'm going to say, well, I know that H is equal to +1 because remember, this is H and it looks like it's -1, but it's really +1. And K would be after that and there's nothing there, so I'm going to put 0. That means K doesn't matter. K's not there. So how is this graph going to move? Well, it's going to move 1 unit right. Is it going to move up and down? No, it's not going to move up and down. So you don't even have to mention it. You don't have to say and 0 units up or down. You would just leave it just like this. This one, you would just grab it and move it 1 to the right. All right, the next one. In the next one, K is equal. Come right up here. It looks like +1, but it's really -1. Sorry, H. Oh, I messed that up. Hold on, guys. That's not right. H. I used the right color, but not the right letter. There we go. H is -1. And K, this time there is a K, and I'm going to get it right this time. K is right here, -3. Remember, K does not try to deceive you. If it looks like -3, it is -3. All right, so my graph here, I'm going to move it 1 unit left this time because I have a negative, and 3 units down because it's negative.